Today we continue with object-oriented programming concepts. So at the last lecture we observed the creation of constructors and destructors. Then we observed the paradigm of object-oriented programming. In the first place, when you create the constructor, you use the name of the class, and then inside it you use the number of parameters and initialize the fields of your class. They have the value that is inside the parameters that you directly highlight in the initialization of your constructor. So constructors may be passed one or more arguments. And when you don't create a constructor, it is called the default constructor. When you don't create specific and you don't initialize it with any arguments, so it will be the default constructor. You can have more than one constructors in your class, and the constructor that will be chosen for initialization will be the constructor with the number of parameters you highlight in the initialization. If you have one parameter and the constructor with one parameter will be used for initialization of the object of the class. So each constructor must have unique signature, and so it means that it must have the unique types and unique number of arguments. In the left side you see the creation of the class, my class. Here you have the field name and field age, so these are the fields. And here you have the constructor that has the same name as my class, and inside it you see a number of arguments. These arguments are the string argument S and byte argument B. Then you use these values C and B to initialize the fields name and S. So here you have the initialization. Then there is also the method, the so-called rewrite, and the method is different from constructors in the way that it can have any name, not just the name of the class. And you can also use any other commands that you wish your function to implement. Then we create a new object of my class. Here we have the new object X. Here it is. So we initialize it with the following arguments. The first string one is Alexander, and the second one is age. So here the object with these arguments will be created, and we can also use a method rewrite. When we call this method, it will use the console output to write down the name and the age. So here it is. This keyword, we have talked about it at the previous class. It is very important when you have the argument and the field of your class with the same name. For example, we have the following class complex, and inside it we have the constructor with the same name, and the argument is of type double. And it has a name real. And you want to initialize your field that is inside the class. So this real is a field of your class, and it has the same name as the argument here. So in order to differentiate them, you must use this keyword. When you use this keyword, your class will understand that it is the field of the class, not the argument here. If you don't use this keyword and you just type real, it will use both arguments. So it will initialize itself with the value of the real. And your argument and your argument will have the same value, but your field will not be initialized with the value inside the complex constructor. So how it works. This distinguishes between the past in real and the real of the current object instance. So you can also avoid this vagueness if you have the just flexible naming strategy, but in the ways you don't want to think too much about the names of your fields and the names of arguments, you can use this keyword to differentiate the different fields and arguments. So here is an example here of my class, and we have the void method here. And the void method too. The first method doesn't change the field value, that is char che. It only reassigns the argument che to itself. But in the method 2, we initialize the field this che with the value che. And another keyword that is very important is the static. So the static members and instances are defined as the instances and that cannot be used as objects. So when you use the static before your class name, it means you cannot create the object of your class. You can only operate at the class level. So you use the name of the class to address this class directly without the creation of object. So such methods are prefixed with the keyword static, and they can only be accessed using the class name rather than through a particular instance, particular objects. So you cannot create an object of the static class. Here we have some example. We have the class myCircle with the two methods, public static double square circle, this one, and the public static double one circle int radius. So as you can see here, we have the static keyword before the name of the method, and it means that we cannot use it inside the object. So here, for example, we want to output the radius of the circle. So we address the class name myCircle, and then we call the method square circle with the argument r. So here myCircle, and inside it we address the square circle method to get the functionality of this method. So we return the value that calculates uh, the area of the circle. Inside the methods that are static, there are some limitations. The first one, in the static method, there must be absent this reference, as such method doesn't work with any object. So as we don't work with any object, we don't use the static keyword. We don't use this keyword inside the static method. In the static method, we use other static methods. So we call other, but not an instance of the same class. This is because static type method is not called for object, so we don't use it. If we use the static class, and inside it we have the restrictions for the data. Inside the static method, we can only directly access other static data. So we observed at the last lecture when we created the static method, and when we try to call and to use the field of the class that is not static, we got an error. So generally, a static keyword is used for methods, constructors, classes, and properties. So mostly for the whole information of the class. Let's take a look at the example here. We have the class myMath, and inside it we have several methods, static methods. The first one, static public int round. Then we have the static public double T, Then we have the static public double square, and we have the static public double sqrt. So the first one will change the value of the change the type of the argument d. The second one will change the type of the argument d and subtract it from the d, so we decrease it. In the third method we find the square of the d argument, and in the first one we find the square root from the d argument. So in the class program, we want to call all these methods. In the first place, we call my mass round this one. Then we call the double this one here. Then we call the square here, and square root. And as you can see, we don't create an object of this class. We address the message directly using the keyword of the class. So my mass, then we use a period, and then we address the method. Overloading methods. Overloading method means that it has the same name. So several methods have the same name, but they're different in the number of arguments and the types of the arguments. Usually it takes place in classes with the constructors, though the constructors are overloaded. This means that we have the same name for the constructors, but different parameters. And when we have these different parameters, we can instantiate our class differently. So we can call different constructors and get different results. But in all the cases, we will use the same name to initialize the constructor. So the methods overloaded. Here you can see we have the class user info. Here it is. Inside it we have four so we have the four methods. Here we don't have the constructor overloading, but we have the methods overloading. So they all have the same name. But a different number and types of its arguments. So the first one is the first one doesn't have any arguments. The second one has only one argument. The third one has two arguments, and the fourth one has three arguments with different types. Here we created the user1 new user info, so we created a new object of the class. Then we call this method UI. As we don't have any parameters inside, so this method will be called. In the second case, we use the constructor or use the method with the 3 arguments. In this case, this one will be called. And we got different console output results, the output results, when we called these 2 methods. And about the properties of C#, the property of the C#, it allows us to get some, so generally the property allows us to assign and to get the values of the fields. So we generally use a property with the same name as the name of the field. Sometimes the properties can initialize the value of the fields that have the access mode as private. So if your field has a private access mode, it means that you cannot directly address it using the instance of your class, using the object. In this way, you need to use a property to address it. So we move further and we have the types of classes. We talked about some classes, like we have static class, or we can have private, public classes. But we can also have the so-called sealed. We also talked about the abstract classes. So we need to talk about other types of classes, like the first one, the sealed class. So when classes are declared as sealed, this is accomplished by putting the sealed keyword before the class keyword in its definition. Sealed classes are used to restrict the inheritance further of the object-oriented programming. As we saw with the abstract class, it is the opposite way. So in the abstract class, we wanted it to be inherited. In the abstract class, when we have the abstract methods, in the inheritance, we override them, we override this class to give some functionality to it. In the sealed class, it is oppositely, we cannot inherit from this class. Once a class is defined as sealed class, this class cannot be inherited. And it cannot be used as a base class. At the same time, sealed classes cannot be abstract, because abstract class means that it will be inherited, and the sealed keyword forbids. So it forbids to do this, so we cannot inherit from the sealed class. Let's take a look at the example. We have the class program, and we have the suit class animal, like this. Suit class animal. Then we try to inherit from this class. Class dog, animal. The syntax is correct. So we have the we have the column here, class dogs, column, class animal. So everything in the syntax is correct. But there is an error that we try to inherit from the class that has a suit keyword. It means if you want to do this, you will need to remove the suit keyword in order for inheritance to work. So in this case, it will not work. When we have the suit method, a suit method overrides an inherited virtual method with the same signature. A suit method shall also be marked with the override modifier. Use of suit modifier prevents a derived class from further overriding the method. So when we use a suit keyword before the method, it means that we cannot override this class in the inherited class. Let's take a look. We have the class A. Here it is, the first class. And inside it, we have the method like this first. This is a virtual method, so we use the keyword virtual. When we use the keyword virtual, it means that we plan to override it. With the virtual, with the second method, we also use the virtual keyword. Then we use the inheritance here. So here. When we use this inheritance, generally we can override. So we use a keyword override, but we also use a keyword suit. And it means that we say that we cannot now override because we have the suit keyword. If we don't have the suit keyword, everything is fine. So we can override. And in this case, we have the class C that is inherited from class B, so the second inheritance. And so we use the override void second. So in this case, we can override this method second, but we have the problem with overriding the first method because we highlighted it as sealed. So in this way, the sealed keywords prevents us from overriding again the first method. So did you catch an idea? So the first we have the two virtual methods. In the inheritance we override them, but then we use the sealed keyword. And sealed keyword means that we cannot further override from it because it's already like this closed for inheritance. So this is a specification of the sealed. And another very popular type of class is the partial class. A partial class is a feature which allows us to write class across multiple files. So this is a key significance of the partial class. So it allows us to write across multiple files. This means that when we use a partial keyword for the class, we can extend its functionality in another file. And all the parts of it must be used with the partial keyword. And all the parts must be available at compile time to form the final type or final class. So all these classes must be compiled and we get the final result. And all of them must have the same accessibility level. Such as public, private, protected, and so on. But all of them must have the same if we use a partial keyword. And here we have one specification. If any part of the class is declared abstract, then the whole type is considered to be as abstract. So in the abstract class, it is highlighted that we need to use the inheritance to extend the functionality of the abstract class. If any part is considered as sealed, then the whole type is considered to be sealed. Let's take a look at the example here. We have the class program, our basic class, where we create an object. Then we have the partial class animals. Actually, the whole. And also the partial class animals. So in this way we have the following fields: animal color, animal name, and we use the method get name here. Console right line, my name is Max and I am dog. And we use the second partial class. Here we have the fields date time, birth date, string, animal, breed, and we have the methods say hi. So now when we can have this in different files, and if we have them in different files but with the partial keyword, they will be combined together. I noticed that the partial class is very is mostly used in the ASP.NET applications, in web applications. When you use the models and the controllers, so they can be classes with the same names, and they are usually partial. So there are also some differences between the struct and classes, as we have talked about it, and they were in your assignments, in your practical assignments. Just on the slide, there are some specifications of class, of both class and the struct. So commonly, if an instance of the type are small and short-lived, or they are commonly embedded in other objects, we define a struct. So the class and struct, as compared one by one, the class is declared with the class keyword, and struct is declared with the struct keyword accordingly. So the class supports inheritance, and the struct does not support inheritance. So the struct is not intended to be the inheritance type. In this way, you cannot use the column and then to use another name of the struct to have the inherited and derived structs. So it is not supported. You can also implement constructors inside the class, and constructors cannot be implemented inside the struct. So data members can be initialized in the class definition, but in the struct, data members can be initialized. And inside, like the reference type where they are kept, so the classes are kept in the heap, and the struct are kept in the stack. So these are different memories, placed in the memory, and the class and struct are kept there. So here on the right part, we have the structure, our structure employee. Here it is. And it has the following fields, like this: employee name, employee job. We can also use a property here, like this public decimal salary. So this property is related to this field, private field salary, because we return the salary type when we get the value, and we assign the value when we use the assignment. But here everything is just like in the class. So we initialize the instance new employee here. Then we address the name, the field name, and we assign it James as a name value. Then we use another field employee job to assign the job name. Then we use the field salary to assign the amount of salary that our employee gets. Another popular another popular instance is enumeration. Enumeration is like a sequence of integer values. Like we have the following enumeration weekday. We use the keyword enum, which means that it will be an enumeration. We have the name, like this weekday, and we have the following fields, like the names of weeks: Monday, Tuesday, Wednesday, Thursday, Friday. By default, these fields are initialized with the 0, 1, 2, 3. But we can change the order of initialization when we assign the specific value to this field. Like this Friday we'll have 40, Saturday we'll have 50, and Sunday we'll have 60. So we use the when we create a new variable of the string type, like this weekday name, and we want to assign it one of these values, so we use the keyword weekday, then we use the Monday, and we want to convert it to string because initially it's of integer type. Then we use a weekday day as Sunday, and then we type it console write while. So another instance of the object-oriented programming is the interface. So an interface contains a definition for a group of related functionalities that a class or struct can implement. So you can imagine it as a contract that all the classes inheriting the interface should follow. The interface defines the what part of the contract, and the deriving classes define the how part of the contract. So we have again the inheritance. The first we have the interface, and then we have the inherited class. So that extends the functionality. The first we just create the upper level realization of the class, and then we define in details exactly how this class realizes some functionalities. Sometimes interfaces are compared with abstract classes, so they have like the following similarities. They can be instantiated directly. They must be inherited, must implement all its members, can contain events, methods, and properties. So they, in this way, they are very close, but they have some differences. They can have method implementation. They allow multiple inheritance, can have access modifiers. Everything is public, so when you use the interface, it's by default only public, so it's in the same name. So like interface, it's always opened, and it cannot contain variables. In the abstract class, you can have method implementation if this method is not abstract. So the class can be abstract, but method can be not abstract. It is not necessary to have only abstract methods inside the abstract class. So it doesn't allow multiple inheritance. Yeah, we only use once the inheritance once from this class, and it can contain access modifiers. So in this way, you can use a whole variety of access modifiers with the abstract class, and it can contain variables as usually. Here is an example of the interface like this. Uh, Public, we have the class program, and we want to have the information about the animal, about the dog. So the first we have the public interface iAnimal. Please take a look here that interfaces are usually called with the first letter as I. It means like the interface. So here you see iAnimals. Public, then you have the interface iAnimals with the method run. Then we have again the interface iDog commands that is inherited from iAnimals. Oh, this one. With the following methods: void stay, void sit, void attack, and we have the property here, dog name. As you see, we cannot have the body of the method. We only have the names here: void stay, sit, attack. Then we have the class animals, this one. With the field animal name and the method void say hi. And then when we use the inheritance, we define the dogs class, and it inherits from the animals, this one, the multiple inheritance. Not this one. The first we inherit from this animals. Then we have the id dog command. This is inheritance from the interface, and we also inherit from the interface trainer. Inside this class, we have the field dog breed. We have the field stay, sit, attack, and run. So as you can see, we define this method inside the idle commands, but we don't have any functionality of the method. We don't have the body of it. And we define this body in the inherited class. So the class dogs. And we can also use a dog name that is a field inside the interface idog commands. So here it is, dog name, and here it is, dog name. So this is examples of the interfaces. So this is what I wanted to show you in our lecture today. So the new ones, we, as a summary, we refined, we revised the concepts of the constructs and some object-oriented that we have talked before. Then we talked about different types of classes, like the sealed and partial classes. And we also defined the difference between the structs and classes. As you had it in your assignment, we gave an example of enumerations and interfaces and we created some interface and inherited from it. So this is like a summary of our lectures today. So please take a look at the presentations that are uploaded to the system, and then you will do the practical exercises that are related to these topics.